Nature does not possess a sense of irony, but if it did, the Pleistocene would be its masterpiece. Imagine a world that has decided, quite simply, that you are a mistake. If muscle and bone were the only currency of the Pleistocene, humanity would have been bankrupt from the start. Against a 3-ton cave bear or a saber-toothed cat with hide like iron, a sharpened stick isn't a weapon, it is an insult. A hand-thrown spear might penetrate 2 inches of fat, serving only to inform a monster that dinner has arrived. Physical evolution takes millions of years. To outmuscle the giants, we would have needed thicker hides, larger fangs, and crushed skulls. But nature gave us none of those. Instead, we discovered a loophole in the biological code. We learned that you don't need to break a giant's spine if you can paralyze its heart with a single drop of sap. We learned that the difference between a fatal wound and a minor scratch isn't the force behind the strike, it is the chemistry on the tip. Long before the first city was built, long before the first metal was forged, our ancestors unlocked the deadliest secret on Earth, prehistoric biochemistry. This is how a hairless primate converted the planet's plants into chemical warheads and cheated the food chain. The transition from prey to apex predator didn't happen because we got stronger. It happened because we learned to outsource our biological lethality. When you look at a poisonous frog, a toxic mushroom, or a venomous root, you see a defense mechanism built by millions of years of natural selection. For almost every species on Earth, that toxicity is assigned to back off. For early humans, it was an open-source biological repository waiting to be hacked. Around 40,000 years ago, during the brutal transition of the late Pleistocene, humanity faced an escalating armaments race. Big game was getting bigger, tougher, and harder to bring down without taking catastrophic losses. Hand-to-hand combat with megafauna was a statistical meat grinder. To survive, our ancestors had to solve a new set of engineering challenges. How to extract lethal nerve agents without dying in the process, how to store volatile toxins on primitive stone weapons, and how to heal the very wounds caused by this dirty chemical war. They turned the forest into a lab, and the tip of an arrow into an execution chamber. A stone arrowhead kills by hemorrhaging. It requires precise hitting power, deep penetration, and a massive loss of blood before a giant beast finally collapses. Often, a wounded mammoth would run for miles, leading hunting parties into exhaustion or death. Enter the chemical force multiplier, the poison-tipped projectile. In the rainforests and grasslands of the ancient world, early hunters identified plants like strychnos, toxifera, and aconitum, sources of curare and aconitine. These aren't just poisons, they are neuromolecular shutdown codes. Curare blocks the acetylcholine receptors at the neuromuscular junction. The target doesn't scream, its muscles simply cease to receive instructions from the brain. The lungs stop moving. The heart falters. A tiny scratch from a poison-coated microlith, a small stone blade no bigger than a fingernail, could reduce a 1,000-pound beast to a breathless corpse in minutes, without spilling more than a spoonful of blood. The engineering challenge was stability. Raw plant sap is thin and washes off quickly. Early biochemists solved this through complex thermal processing. They boiled down saps, mixed them with tree resins, sticky gums, and even crushed toxic beetles to create a viscous, deadly paste that could adhere to wood and bone for months. Without firing a single heavy projectile, a small team of hunters could track a herd, leave an invisible scratch on 3 giants, and simply walk behind them until gravity did the rest. It was the invention of long-range biological assassination. Plants were only half the equation. The natural world had already perfected organic chemical synthesis in animals, and prehistoric humans were quick to harvest it. In tropical regions, ancestors discovered the Dendrobatidae, the poison dart frogs. A single golden poison frog secretes enough batrachotoxin through its skin to kill 10 grown men or 2 bulls. Batrachotoxin forces the sodium channels of nerve and muscle cells to stay open, causing permanent depolarization, massive heart arrhythmia, and total muscular contraction. Harvesting this was a masterclass in risk management. Early humans didn't touch the frogs with bare skin. They used leaves to handle them, gently heating the creatures over a fire to force the sweat glands to release the toxic cocktail. They coated arrow tips not by dipping, but by carefully rolling the bone tips along the frog's back, creating a microscopic layer of death that remained active for up to a year. Think about the psychological shift this caused. A monkey in the canopy or a predator in the brush was no longer a threat that required risky close-quarters combat. The bow and poison dart allowed a human to deliver a fatal dose of neurotoxin from 50 yards away, silently, invisibly, and without revealing their position. We didn't just invent hunting weapons. We created the world's first silent, long-range guided missile system. If you handle poison every day, you will eventually poison yourself. Furthermore, in a world dominated by dirty wounds, animal bites, and gangrene, chemical offense was useless without chemical defense. For decades, historians assumed that ancient humans treated infection with superstition, chance, and fire. Then we found Otzi the Iceman, a 5,300-year-old mummy preserved in the Alps. Tucked away in his travel kit were two carefully preserved leather strips holding birch polypore fungi. This wasn't food, and it wasn't tinder. Modern chemical analysis revealed that this fungus contains toxic oils that act as a natural laxative to flush out intestinal parasites, along with piptamine, an organic antibiotic compound. Otzi wasn't carrying a lucky charm. He was carrying a targeted pharmaceutical prescription.
Is that the mandible?
Deep in Neanderthal burial sites like El Cidrón in Spain, plaque analysis on 50,000-year-old teeth revealed trace chemicals of chamomile and yarrow, plants with zero nutritional value, but high concentrations of anti-inflammatory and pain-relieving compounds. Even more astonishing, one Neanderthal with a massive dental abscess was found to have ingested penicillium fungus, the source of penicillin, and poplar bark, which contains salicin, the active ingredient in aspirin. They weren't eating blindly. They understood symptom, cause, and chemical countermeasure. They were running clinical trial and error across tens of thousands of years, building an unwritten encyclopedia of pharmacology inside the human memory. We like to think of modern pharmacy and chemical warfare as products of the Industrial Revolution. We view our ancient ancestors as primitive, brute savages who threw rocks and ran from shadows. The truth is far more humbling. Our survival didn't come from the strength of our arms, but from our ability to look at the venomous, toxic, and deadly elements of the natural world and see them as tools. We learned to extract the invisible molecules of death to hunt, and the hidden molecules of life to heal. Long before the laboratory, the white coat, or the microscope, the human brain was already the ultimate biochemical engine. The saber-toothed cats had the fangs, the mammoths had the armor, but the naked ape had the needle, the frog, and the mushroom. The megafauna are gone, but the chemistry remains. If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and let me know in the comments what topic you'd like to see next.